Alright guys, welcome to your 43rd tutorial, and in this lesson we're going to be learning about dogs. So you know how people say that dogs can hear better than humans? Well, actually whenever they're saying that, what they really mean to say is dogs have a wider range of frequencies that they can hear at in comparison to humans. So dogs can actually hear at the frequencies from 40 hertz all the way to 60,000 hertz. Now remember that I said is a hertz whenever we talk about waves is basically one cycle per second. Now, whenever we're talking about sound waves, we know that sound are just vibrations in the air. So this means that if you were a dog, your ear could pick up on anywhere from 40 vibrations a second to 60 vibrations of air per second, and you would perceive that in your little doggy brain as sound. Pretty sweet, huh? So now let's go ahead and take a look at the formula. V equals wavelength times frequency, and say that someone asked us to calculate the wavelength that this range is. So the wavelength for 40 hertz all the way to 60,000 hertz. Well, let's go ahead and start filling in these variables right now. Velocity is how fast are these excuse me, sorry, just ate a Hot Pocket. How fast are these waves going to travel? Now, we know that all sound waves travel at 340 meters per second. How do we know that? Because that's just the speed of sound in normal air. Now, I know this doesn't have anything to do with this lesson, but just a fun fact. Whenever the molecules are closer together, they travel faster. So since water molecules are closer together and more jam-packed than air molecules, the speed of sound in water is up to 4 times faster. And actually in solids like copper, and I know it's kind of weird to imagine a sound traveling through, a piece of copper or something, but the speed of sound in copper is, I think, 4,600 meters per second. It's like 13 times faster than air. But anyways, just remember that the speed of sound in air, 340 meters per second. That other stuff was just me rambling on. So what we want to do is we actually want to find the wavelength of these 40 and 60,000 hertz. So we'll just go ahead and put a question mark right there, because that's what we're trying to figure out. Now the last variable of frequency, well, our teacher asked us to figure out 40 and 60,000. So I'll just put 60,000. I'll leave the units off there for now. Now the very first thing we need to do, if we take a look at this formula, this is a formula that solves for velocity. However, we already have velocity, so we need to change this formula up to suit what we're looking for, and that is wavelength. So the formula rewritten would be wavelength equals velocity over frequency. So let's go ahead and do one at a time. We'll start with the lower frequency, which is 40 hertz, or 40 vibrations per second. So in order to figure this out, we'll just go ahead and set wavelength equal to velocity, which is 340, over 40. And once you cancel out with all the units or something, you can see that the lower wavelength that a dog can perceive is 8.5 meters. So if anyone comes up to you and is like, dude, Bucky, if dogs could see sound in the air, I wonder how long apart the waves would be. And I could say, well, on the lower frequency, they would be exactly 8.5 meters apart. And they're like, whoa, Bucky, I'm impressed. How did you know that? I'm like, don't worry about it, bro. But anyways, ask me another question. And they'll say, what about the higher frequency of 60,000? So of course, I got to go do the math for this. We'll just go ahead and keep the same formula. It would be 340, because the velocity doesn't change. The only thing that changes is the frequency, which is now 60,000. And once you do the math, you get a range of 0.0057 meters. So again, one last time. If you were a dog with superpowers and you could see sound in the air, then you would notice that the waves would be either 8.5 meters apart or 0.0057 meters apart, depending on the frequency of the sound.